Now, the probability that a test will correctly reject the null hypothesis when the null hypothesis is false is what we call the power of the test. There is power in rejecting the lies. Now, type 1 errors and power are directly proportional, which means they typically change in the same direction, whereas type 2 errors and the power of the test are indirectly proportional. Now, what does that mean? I'm so glad you didn't ask, but here we are. We have a few concepts here, and we have this relationship or this table between type 1, type 2, and the power. So we know powers of a test and type 1 are directly proportional, so these two should change in the same direction, whereas the power of the test and type 2 are indirectly proportional, so they should change in opposite directions here. So I'm going to use this applet, and we can see here that here's the truth parameter. Here, or hold on, the null hypothesis, the value of p. All right, here's the truth, here's the fake. Here you can see the null, right, is this. And the blue here is the alternative. So we can see the relationships of the errors here. So let's suppose that I'm actually getting my null hypothesis closer to the truth here. And as I'm getting closer to that 0.5, notice that my type 2 error is increasing and my power is decreasing. So what if I get it really far away? Oh, if I get it really far away, they change. Power is 100%, type 2 is 0%. So you can see here that as we change the distance from the null and the alternative, we can change the power and the type 2 error. Now, let's suppose that we increase our sample size. For some reason, that was set to a sample size of 46. Well, what happens when we increase our sample size? Look at that, y'all. Okay, so look at the power and the type 2. I'm going to do that again. So let's suppose we are back to 46. There's our type 1 error and power there. So let me take a smaller sample. Oh, when I take a smaller sample, my power decreases. So then back to the original. When I take a larger sample, what's going to happen? As sample size increases, power increases and type 2 error decreases. Now, one of two reasons. And actually, am I able to show it on here? So you see this green portion here, that's the power of the test. And the blue portion is right here, because again, these are inversely proportional. So as I'm increasing that sample size, right, larger samples have less variability. So as the spread, right, or our standard error is decreasing, right, and it decreases as sample size increases, we can see that the power and type 1 errors are actually both increasing, whereas the type 2 error is decreasing. So that's in increasing, and if I go in the decreasing direction, we can see everything's kind of changed. So now we can see these different components. And then, of course, the last thing here, if I move my significance level, you can kind of see here that both the power, so the green and the red, which is the type 1 and the power, they're increasing. And type 2 is decreasing. So this is just a really fun applet to look at how changing certain aspects of your known information changes your types of errors and your power. So if we increase the sample size, we saw the following happen. We saw that as we increase the sample size, a type 1 error increased and the power of the test increased, which means the type 2 error decreased. As we increase the significance level, or what we call alpha, since we're increasing alpha, of course type 1 will increase, so will the power, and type 2 will decrease. Now, as the standard error decreases, so as it gets smaller and smaller, right, the spread of the distribution, as it gets smaller, you're shifting these regions over. So your alpha level is actually going to increase, right? 10% of something smaller is going to be worth a little bit more. So here, I guess you've kind of figured out the pattern of this. And then lastly, the true parameter value is further from the null hypothesis. As you increase the distance, the power and the type 1 increase, whereas the type 2 will decrease. So this table's helpful to know. You by no means need to memorize if you're able to kind of see that justification in your head. If not, go back and play around with the applet until you've got it down. But here we can see that these concepts generally follow these trivial patterns. So, which of the following result in the power of the test being the least? Well, if I increase my sample size, my power decreases. So clearly I don't want a larger sample size. And then the smaller the significance level, the lower the power. So here, option 1 would give us the smallest power, which means option 4 would give us the largest. So this one would be the smallest, and then this option down here would be the largest. And again, you could actually plug these into the applet and check out to see what happens. Now, what would happen to the power of the test if the significance level was changed from 0.05 to 0.01? So alpha, right, our significance level changes from 0.05 down to 0.01. So we're losing some of that shaded rejection region, which means now power will decrease. And since power is decreasing, type 2 error will increase, again, because those are inversely proportional. So type 1 in power, directly proportional. Power in type 2, inversely proportional. And then lastly, suppose the significance level is changed from 0.05 to 0.10. What happens to the probability of the type 2? Well, now significance is increasing, power increases, type 2 would decrease. So there's just a few concepts there. Normally this shows up in maybe 1 or 2 multiple choice questions in the stats exam, but it's helpful to know what to do. What does it mean? What are the consequences? What are 4 ways you can modify these probabilities, etc. So that's going to be our study on types of errors and power.